So a variable font is a font that behaves like multiple fonts. And up until now, all styles such as bold, italic, semi-bold are stored as separate font files. So you would have a file for bold, italic, etc. And variable fonts allow type designers to combine all these styles in a single file. And this is not just a compressed zip file. But instead of storing each individual style, variable fonts store one or more styles together with instructions for how to interpolate between those styles. And I thought it would be interesting to take a little look at how this interpolation works. But before I can do that, I need to tell you a little bit about fonts. So all characters in a font are stored as vector graphics, just like SVG. So for example, take this E from the Acumen typeface. These little red circles and squares are the control points. It's very similar to what you would get in, for example, Illustrator when you're doing vector graphics. Now, if you want to increase the weight of this E, so to make it bolder, you need to move these control points. So for example, we're going to move it to where that thin outline is there. And some points stay in place and the others move. So the red arrows indicate where the control points go to. And if you do that, you get a bold E. Actually, this is a heavy bold. So in traditional fonts, these two versions will be stored as separate font files. One for the regular weight and one for the bold weight. But variable fonts are different. So instead of storing each weight as a separate file, variable fonts store the offset based on the master outline. So in this example, it would store the data points for the control points in the master. This is the black part here. And the interpolation data to get from this normal weight to the extra bold weight. So for each point, it would store an offset from its master position. And you're not limited to interpolation in one direction. So take this E again, and you can interpolate it all the way to an extra bold weight. And you can also go in the other direction to create thinner weights. So the variable font only stores the control points for the character, highlighted in red here, plus the interpolation data to get from the red to the thinnest and the heaviest weight. And it's not just limited to font weight. You can choose to interpolate to any points between these two extremes. So if you want something like rise in between here, you can do that with variable fonts. You can just say, I want that exact weight. And in variable fonts, this is called an axis. And variable fonts can have multiple axes. So there are 5 standard axes. You have width, weight, italic, slant, and optical size. The width axis makes a font narrower or wider, and the weight axis makes a font bolder or thinner. And the italic axis applies italics. The slant controls the rotation, if you have a font that does that. And optical size controls, well, the optical size. Maybe I should explain optical sizes shortly. So some fonts have like special display versions of a character that are meant for use in larger font sizes. So in this example, the optical size makes the features of the K more delicate at larger sizes, so it looks nicer. But it doesn't work well at small sizes. Now, of course, not every variable font will have all the axes. It's up to the type designer to decide what you will get. And these axes are not standalone. You can combine them. So for example, this shows the width, weight, and optical size axes visualized as a 3-dimensional space. And you can select any point in that space to get a completely unique font. And in variable fonts, we call this the design space. And you're not actually limited, you're not even limited to the default axis that I showed you. You can have custom ones as well. So you can have 1 axis, you can have 2, 3, up to roughly 65,000. So there's a lot of room there. And I actually tried to create a font with 65,000 design axes, but it crashed my browser, so I don't know. Maybe don't do that. But basically, type designers can come up with anything crazy, and they do. So this is a variable font called decovar, and it has a lot of access to do, well, weird stuff. You can enable serifs, you can turn it into a geometric sans, you can have little things that stick out from the typeface, patterns. I don't even know what to call half of these things, but it's pretty crazy. But this enables a lot of experimentation, which I think is good. And, well, you knew I was going to bring up this slide. So this is a demo using decovar by Mandy Michael. And it's made entirely with variable fonts and CSS effects. So you can, as was pointed out before, you can type with this text. You can do anything with it that you can with normal text. And this basically simulates a grass growing effect using the little things in the typeface that stick out. I won't go into detail about how she accomplished this. She actually gives a really good talk about it as well, so you should definitely check that out. So there's another example by Mandy. She does a lot of crazy stuff. So this one uses CSS text shadows and animations to create a effect. I'm not sure how to describe it, but it's cool. Mandy has a lot of other examples. I really recommend you check out her CodePen collection over there. Now, variable fonts can be controlled through CSS, but because you can modify CSS with JavaScript, you can actually control variable fonts using all the available web APIs. And people have been doing all sorts of experiments with that. So I've seen people controlling variable fonts using the gamepad API, motion sensors. And this one, I don't think I have sound, but it's OK. So this one uses the sound API to react to sounds. So it changes the font when you're clapping. I'm not sure how useful that is, but it's cool. So here's another slightly more useful experiment by Tom Lockhorst. And he's using the ambient light sensor API to react to the amount of light that's in the environment. So when it's very light, the text is the normal width. And when he covers the sensor, it gets dark. And the text becomes bold, so you can read it more easily. So that's pretty cool. Now, people are also experimenting with novel typeface designs. And this is one of my favorites by type designer David Jonathan Ross. It's called Fit, and it's a variable font designed to take up all the available space. Can anyone read what it says? No? OK. It says, Fit is designed to fit just about any text into just about any space. And I'm in love with this typeface. It's awesome. So you can start typing, and it will just resize things. This says variable with an exclamation mark. It's not very readable, but it's cool. Other people have completely gone off the deep end with variable fonts. So this is a font by Toshi Omigari that consists of a pixel grid where each pixel can be turned off and on using a variable axis. So basically, each pixel in this font has its own variable axis. And if you layer 3 of these characters on top of each other, and you color them with red, green, and blue, you can use it to display video or anything, really. I'm not entirely sure of the practical applications of this one, but again, it's cool, so why not? So this is an example by Andrew Johnson showing variable fonts used in augmented reality. So this text is actually not on the screen, but it's projected on top of it in 3D. And you can see that the typeface changes depending on how far you're away from the 3D surface. So you may be thinking now, variable fonts sounds pretty cool and interesting, but when can I use them? Well, I have good news for you. Browser support is pretty damn awesome, I think, for a technology that pretty much was announced last year. All major modern browsers support it as of about 2 weeks ago. So globally, browser support is about 72%. There's still some other browsers that don't support variable fonts, but support is good enough that you can start using them. You can start experimenting with them. So how do you use them in CSS? So you start basically by writing your font face declarations as usual. So you would have a font face rule with your family in there. You point to one or multiple font files, and then you include all your regular styles that you want to use. I didn't list all of those out because it usually gets rather long. And then you create an extra font face rule for the variable font. And there are two things here that stand out. First, the font family is different, and I'll get back to that in a moment. And the second is the font weight descriptor, which looks a bit odd if you've never seen it before. It basically defines a range, so it tells the browser that this font supports font weights from 1 to 999. So you use this in your CSS by first using your regular font, like your old-fashioned font files, as your default font. So you apply the font to your body element, for example, and then you use an add supports rule to apply the variable fonts only when the browser supports variable fonts. And you do this by testing for the existence of a new property called font variation settings. And I'll explain what that property is and how to use it in a little bit. But for now, we'll just use it to find out whether or not the browser supports variable fonts. And if it does, we override the font family for the same element to include the variable font. And that means that in browsers that support variable fonts, you'll get the variable font, and in browsers that don't support variable fonts, you get regular font files. And then basically you apply your styling as normal. So for example, most regular font files have weights ranging from 1 to 900 in increments of 100. And in CSS, you would use like font weights 400, 700, etc. And that's pretty much the same with variable fonts. You just use the numbers that you're used to. However, you can also enter new values. So if you want font weight 250, you would set font weight 250 and get exactly that font weight. Or you can do font weight 487, if you really wanted to. And the weight will be interpolated to the exact weight that you asked for. Now, so this is new for the font weight property, but the other font properties have also been extended to support variable fonts. So you can control the width axis with font stretch, and in addition to the existing values, it now also takes a percentage. And 100% is defined as a normal value. So if you set it to, for example, 200%, you would get an ultra expanded font. And if you set it to 98, for example, you would get a slightly condensed font. Now, as I showed you earlier, the font weight property has been extended to take any number from 1 to 999. So you can tweak that to your heart's content. The italic and slant axes have been rolled into the font style property, which now takes an additional angle value, which allows you to specify the angle of the typeface. And italics can be enabled as usual using the italic keyword. There's also a completely new property to control fonts, optical sizes. So if you set it to auto, the browser will automatically enable optical sizes if you increase your font size a lot. And setting it to none disables it. Interestingly, the default value for this is auto. So if you have a variable font that supports optical sizes, you will automatically get optical sizes if you have large type. So I said I would get back to the font variation settings property. It allows you to control the custom axis in variable fonts. And its syntax is very similar to the font feature settings property that you might have used for OpenType features. And you can set values for one or multiple design axes. So here at the top, I'm showing the default value of decovar, which is the normal design. And in the middle, I'm setting an axis called SKLD to 600, which I think means stripes. At least that's the effect anyway. And then the last one at the bottom is the combination of SKLD and BLDB, which I believe is a combination of stripes and squiggly things that stick out. And it's likely that we'll see more high-level properties for these things as design axes are standardized in the working group, which is what happened with OpenType features as well. But right now, this is all you need to access every design axis in a variable font. And I think a good thing about this is that you can use CSS animation, you can use transitions, you can use variables on any of these properties. So I'm not sure why you would want to do it, but you could, for example, animate the font weight like I've done here with some pretty straightforward CSS. You can say the keyframe that I create here goes from font weight 1 to 999, and it will just do it for you. Don't do it right now, because if you do it, Chrome will crash, but that's being fixed. So I have to apologize in advance for the next slide, but I have to show it because it's a novelty. So this is the world's first color variable font. It's by a strange Dutch guy, and I say that as a fellow Dutch person, so it's okay, called Roel Nieskens. And it has one axis to animate the head of the pile of poo. And he created an axis called crap. And you can use that to change the height of the hat. I didn't come up with it, but there it is. So maybe this is also news. You can also have color fonts. I don't know if anybody was familiar with that. So the OpenType, yes, I know you are. The OpenType font specification has been extended to support color fonts, which actually works by putting SVG into a font file. So, but that's a whole other talk, actually. So I think soon we'll start seeing animated variable color emoji fonts, which is it's going to be interesting. Now, so far I've shown mostly fun or weird examples, but variable fonts also have some very practical applications. And one of them is tweaking styles to be just right. So for example, font weight, and this example here, there's a piece of text and a headline set an exact same font size and exact same weight. But due to an optical illusion in your eyes, it looks like the white text on the black background is slightly bolder than the other text, even though it's exactly the same. Now, before variable fonts, you would, if you were bothered by this, and some people are, like me, you would either need to accept this or move down a weight, right? You would have to change the font you used. But then usually it's a little bit too much, and then it doesn't look right again, and it's like, it's not nice. But with variable fonts, you can tweak your styles ever so slightly, so that it looks like this, for example. So I kind of tuned it down a little bit, so it looks exactly the same, even though it's not the same, but it's optically the same. And it doesn't only apply to light text on dark backgrounds. If you think your bold is a little bit too bold, you can just tune it down a little bit, make it less bold. So if you like a typeface, but you wish it was just a little bit wider, then just change it. So the possibilities are really endless. Which I think, I don't know how many of you are designers, but usually designers go like, yes, I can tweak everything now. So another useful application of variable fonts is in Justification. So this is an experiment I did a couple of months ago for another conference, and I think I should probably very briefly explain how Justification works. So here's a justified paragraph as if it was in a browser, and there are several problems with it, in my opinion at least. There's a lot of space in the third row here, and also the second and fourth lines, there's a lot of extra space there. So you can get an idea of how bad that is by highlighting the extra space, and that is the space that is added by the justification algorithm, because it's trying to make an even rag, right? And you can see that it adds an extra space to each line, except the last one, which is left aligned. But it's really hard to estimate how bad it is, really. So instead of highlighting the extra space, I'm going to add a little graph to the right column. And this bar chart represents the sum of all extra space in that line. And then it's really easy to see when a line is good or bad. The last line doesn't have a graph because it's not justified, so I just left that out. Now, you can see when you change the width of the column, you can see that the bars change, and it gets really, really bad when you make the column very narrow, which happens a lot when you're setting text in smaller screens. So for example, if the column width is 250 pixels, like here, then we have a lot of extra white space. By the way, the score at the top is the sum of all the extra white space in the paragraph, and lower numbers are better, of course, because you don't want too much white space. Also, the greedy is because this algorithm is called the greedy algorithm, but I won't go into details on that one. Now, of course, you shouldn't use justification without enabling hyphenation. So let's do that and see what happens. So this is before hyphenation, and this is after. And it could only hyphenate one word in this paragraph, the word astonished, but it already improved the score a lot. It actually went down by more than half, which is really good. And this, unfortunately, is the best typesetting you can get in browsers. But it's possible to do better, actually. Not in browsers, but outside of browsers. And that is by using the same justification algorithm that is used in like tech and InDesign. And this is called the Knuth and Plas algorithm after its two inventors, Donald Knuth, the famous computer scientist, and Michael Plas, which was one of his students at the time. The algorithm tries to optimize the amount of extra space over the entire paragraph instead of line by line. It does this by trading slightly contracted word spacing in some lines for a better overall result. So in this case, it contracts the word space in the, what is it? Well, that one line over there, fifth line? Oh, sorry, the sixth line, to get a more optimal word spacing in the lines that follow. And this creates a small improvement at this width. We went down from 180, a score of 118 to 93. But if you look at a more narrow column, you see a much bigger improvement. The score is almost half. Now, unfortunately, web browsers don't support this algorithm because it's considered too expensive. I've been fighting the W3C on that for years, and I've been losing so far, but one day I'm going to win. Anyway, this produces much better results, but it still adds a very noticeable amount of space to some of the lines. And even without looking at the graphs, you can still you can see that several lines have too much white space in them. So that's where variable fonts come in. Now, if you remember earlier, there's a width axis which allows you to change the width of a font. So I started wondering if you could modify the justification algorithm so that it uses the width axis to, instead of expanding the word spacing, it would expand the words themselves. And you can. So this is before, this is like the best typesetting you can get these days. And this is the best typesetting you can get with variable fonts. And it reduces the score to 8.2. And it's very hard to kind of find where the extra space is added. And this produces a much more even typesetting. There's still some extra white space in the second line because I only allowed it to use +5 and -5% of the width axis, because otherwise you would get words that are stretched completely too much. But overall, it produces very good results. And you can see that in more narrow columns. So this is before, this is state of the art, and then with variable fonts, it is much better. You get like half the score. Now, variable fonts also have great potential for performance improvement. And as you've heard from Peter this morning, there are some performance issues with web fonts. And one problem is file size. Loading a lot of styles adds up to a lot of kilobytes. So for example, this is the entire Acumen font family, and it has 90 individual styles ranging from extra condensed to wide and from thin to ultra black. Now, all 90 styles of Acumen add up to 3.9 megabytes using regular old font files. And that's actually using WAV2 compression, so that's like the best you can do. But the variable font version of Acumen is only 270 kilobytes as a WAV2 file. So that's huge. I mean, that's about 93% smaller. Of course, you wouldn't use all 90 styles, but with a variable font you could, and I think that's an important distinction. So let's take a look at a more realistic use case. This is an article from Wired.com, and it uses 5 different typefaces. So I'll just highlight them for you. And in total, this page loads 38 different font files. There are a couple that are not in this list here because they come from ads or from our icon fonts or something like that. But it's a lot of fonts. But the main 5 typefaces add up to 11 font files. Now, if you use variable fonts for this, you could cut that number in half. You could go from 11 font files to about 4 or 5. It's really hard to say how much of an improvement this will be because none of these particular typefaces have variable font versions available yet. Though, I mean, they're pretty popular typefaces, so I assume they will come soon. But I've done a couple of experiments, and I've seen file size reductions up to 50% in real-world situations. And it's not only a benefit for file sizes. You're also going from several font requests per family to just one will make a big difference, especially if your fonts are in the critical rendering path. So if you're using an HTTP1 server, and even on HTTP2, you have fewer resources to compete over the same connection. Now, it's really hard to kind of give a very general statement about whether variable fonts will absolutely be performance improvement or not, because it depends on how you use the font and the font itself as well. So for example, if you have 3 weights from the same font family, such as bold, regular, and extra bold, you'll probably see a performance improvement. But if the font contains multiple masters per axis, like the deco var thing, then things get rather complicated. So you should always check before using variable fonts. So, are variable fonts the future of web typography? Yes, I think so. There's something for everyone with variable fonts. Type designers can experiment with a whole new way to design their typefaces. Designers can tweak styles or create more expressive typography. And developers can use variable fonts to optimize their websites. And on top of that, adoption is pretty great. Like, this technology was announced 2 years ago, and we already have browser support for it in all major browsers and operating systems. And we're starting to see support in apps like Photoshop and Illustrator and stuff. And also we have a lot of commercial typefaces that are coming out right now that have variable font versions. So the offering is growing rather rapidly. So at the very least, now is a really great time to start experimenting with this new technology. I have a couple of resources if you're interested. This Access Praxis, which is a playground for using typefaces. Variablefonts.com, which is a website where you can see pretty much every variable font that was ever created. And there's another website where you can play with them. That's it. Thank you.
Thank you.
Thank you, Bram. Let's go to the interview. So, thank you for your talk. It was really inspiring. So, the first question I want to ask is there any good fallback for variable fonts? For example, I want to use it. Is there a really good fallback that
Well, like as I showed you, you could have your you could load your regular font files on browsers that don't support it. But if you ask for, let's say, a font weight of 250, and there's no regular font files that has that, then you will get a slightly different weight if you fall back. So that's actually one of the big problems that we still need to solve.
Okay.
And how many different fonts we can fit in one variable font?
How many fonts? Yeah. That's an interesting question. There's a type designer in the Netherlands. Again, I don't know why Dutch people are so weird, but that created a variable font that contains all possible typefaces.
Wow.
Just by putting a pixel everywhere and just changing it so that it looks like the typeface. So I guess that's not a realistic answer, but...
how much does it weigh?
I think it wasn't that big. It was like 60 kilobytes or something. But the problem with it is that there's a lot of control points to do that, and that makes the rendering very slow, so you can't really use it realistically speaking.
By the way, I have a question that connected to the next talk tomorrow. There was an experiment with neural network and algorithms that learned those parameters by neural network and actually generated fonts by themselves without those parameters. So what do you think? Will AI kill variable fonts some days, or variable fonts are more flexible than any computer can do?
Ooh, that's a loaded question. I'm not a type designer, so I'm saying maybe. If you ask a type designer, they would say no, like a computer can never reproduce my artistic skills. But we'll see, I guess. We'll have to try and see what happens.
Okay, thank you.
Thank
you a
you
lot.
very much.